Hello class, my name is Logan Andrade, and today I'm going to be presenting the CRJ 200 fuel system. Alrighty, a little introduction. The fuel system comprises of 3 integral tanks and the structure of the wing box. The fuel is supplied to each engine by ejectors and electric boost pumps. An independent system supplies fuel to the auxiliary power unit, APU, and the fuel system provides provision for the pressure refueling / defueling and gravity refueling / defueling. Power and gravity crossflow systems provide facilities for transfer of fuel between the wing tanks. Refueling is also automatically controlled by a fuel quantity gauging computer, and the crossflow of fuel and fuel transfer automatically controlled by the FQGC, as well as the FQGC calculates the fuel quantity and the temperature to report the ECAS display. The ECAS depicts a diagrammatic view of the fuel distribution system, and the operations of the ejectors, pumps, and shutoff valves, which we will discuss further on, are graphically shown, as well as the resultant of fuel flow. Any malfunction detected by the fuel quantity gauging computer is displayed in the form of a visual message. Alrighty, moving forward, as you can see, our fuel tank quantities for the CRJ 200. We have a left main tank, a right main tank, as well as a center tank. Our usable fuel, unusable fuel, and total fuel. Usable fuel is going to be the same in the left main tank and the right main tank. It's going to be 7,493 pounds. Unusable fuel is going to be 62 pounds in the left and right main, and the total is going to be 7,554. And our center tank is going to consume of 4,610 pounds usable, unusable 32, and total fuel is going to consist of 4,642 pounds. Moving forward through your private, instrument, commercial, you should have learned that unusable fuel, the reasoning for that is because of debris and excess dirty fuel sits at the bottom of the tank. And that's going to pretty much sit at the bottom, and the fuel flow driven into the engine is going to be slightly above, which is going to hold that 62 pounds underneath to keep that dirty fuel out of the tanks. Moving forward, we have our fuel feed, which is going to supply fuel from the wing tank fuel storages, which we discussed. We have our left main, right main, as well as center tank. There's a boost pump in every wing tank, such as a auxiliary power boost pump that you have in your Cessnas, Archers, etc. That's pretty much going to draw fuel into the engine from the tanks. It's going to boost it into the engines. That's while starting up. While engines running, the engines are going to begin running, the engine-driven fuel pump becomes active, and that's going to feed the fuel into our engines. The boost pumps typically turn on when the engine-driven fuel pumps are running, or turn off when they're running, but they are needed for critical phases of flight that you guys know of, such as takeoff, landing, etc. Alrighty, fuel display. So we're going to have 6 ejector pumps. Our ejector pumps are pretty critical. We have 2 main, we have 2 transfer, as well as 2 scavenger. Our 2 mains are going to move fuel from our collector tanks to our engines. The 2 transfer pumps are going to move fuel from our center tanks to our main tanks, and then our 2 scavenger are going to move fuel from our main tanks to our collector tanks. So they're all working in a process to get fuel driven to our engine. Alrighty, moving forward, we have our fuel transferring methods. We're going to have different types of methods. One's going to be our fuel tanks, the way we just talked about how our boost pumps contribute fuel moving through our tanks, which is going to consist of our transfer pumps. We have our cross-flow valves, which are going to pretty much move fuel from one tank to the other due to a improper fuel balancing in our tanks. which we also have an automated fuel balancing, which automatically balances our fuel if there's more of a 200-pound difference in our tanks. And then we also have our engine pumps. So that's going to be our way of transferring fuel. Alrighty, moving forward, we have a diagram up here. Looking at the diagram, you can see we have 11 shutoff valves. We're going to have 3 fuel pumps, one in each tank, left main, right main, as well as center. And we're going to have a right and left boost pump, APU cross flow pump as well, if needed. We're going to have our fuel indicators on our next slide. We have different ways of indicating fuel. We have a fuel quantity indicating system, which is pretty much going to indicate how much fuel we have in each tank. In flight, we have our probes, we have our cross-flow system, as well as our ECAS display. And we're going to discuss our ECAS display in this next slide. Alrighty, we have our CRJ 200 ECAS. We have our engine indicators and gauges, which is going to display pretty much our engine indicators are going to be our ITT, N1, oil pressure, oil temperature, etc. That's going to give us pretty much our engine indicators. Crew alerts. Crew alerts can mean multiple reasons why. It can be anything that's critical in flight. It's going to alert us if needed. And then we also have our aircraft system indicators. Alrighty, and we have our references. I use the Bombardier CRJ fuel system on the Bombardier page. I think it had a great indication and great examples of our and diagrams of our fuel system, and it was an easy way to learn how the CRJ fuel system works in the CRJ 200. I appreciate you guys listening. Thank you so much.